Hello everybody, how are you all? Are you studying regularly? Today we are going to start our geography part lesson 3 Motions of the Earth. Motions means movements. In our previous chapter, you learned about the shape of the earth by learning about its miniature model, the globe. You also studied that it has an axis on which it rotates. In this chapter, we shall study about the various motions of the earth and their effects. The most important two motions of the earth that we are familiar with, the rotation and the revolution. Now, to explain the rotation, we have the spinning top. You must have played with it. It has a pin and it remains vertical as long as it spins. Our earth also rotates like this. Rotation means movements of the earth on its axis. So our earth also rotates like this on its axis. For one rotation, how much time it takes? 24 hours. We won't feel this movement. What is the reason, children? Because all the other things that is here also moving with us. We also feel sun rises from the east and sets in the west. Actually, sun is fixed or unchanging and earth is rotating from west to east. Now, because of rotation, we have the day and night phenomena that occurs. But, that day and night that phenomena occurs. While rotating, one part of the earth will face the sun and other part will be on the opposite direction. This happens gradually. The part faces the sun have day and the opposite part will have night. In this picture you can see that when we look at the sky, we feel the sun appears on one side of the horizon, then slowly rising up the sky. Then it reaches on top and then slowly going other side of the horizon. This we say first dawn means the period of spreading light before sunrise, then day, noon, evening, dusk and last night. Okay. Here you can see the different positions of the earth as it rotates taken from the space. Children, now we will move to the next page. It is written, Japan is known as the land of the rising sun. Why? We know that the sun rises in the east. Since Japan is the farthest country in the east, this country gets the first sunlight of a new day and so it got this title. We know that the earth rotates in its axis. When the earth rotates, it exactly does not upright. In fact, it tilted. The axis of the earth is tilted at the angle of 23.5 degree from the vertical. This means that if a line were drawn parallel to the plane of the earth's orbit, the earth would make an angle of 66.5 degrees to this line. This tilt has some effects on the earth that we will study later. Next, we will study the effects of the earth's rotation. Effects of the earth's rotation. Because of this rotation, one thing, we are able to live in this earth. Now we will see if the earth stop its rotation, what will happen here. First thing, the earth's one part would be always face the sun. Then there always day and the opposite side. Always there would be night. Then where the heat falls, there would have extremely hot and the other side extremely cold. If it is extremely hot and cold on the earth, then there won't be life on the earth. Last point, if there is no rotation, there would be change on the winds and ocean currents. Now we don't have much problem. Next point is revolution. Simple way we can say revolution is the movement of the earth in its orbit around the sun. In this picture you can see. When we look at this movement of the earth from space, that we look at from the earth's north pole, we would notice that this movement is in the anti-clockwise direction. Which direction? Anti-clockwise direction. The earth's way or path is called the orbit. You can see in the picture now that line. It is not circular, but we can say it is oval shape or elliptical in shape. See in the picture, when you look at this diagram, you will understand this shape. That oval shape only, no children? Now we will see Earth's orbit. We have already studied the Earth's orbit is elliptical or the shape of a closed curve. Okay children? What is the average distance from the Earth to the Sun? Yes, it is 150 million kilometers. When the Earth comes closest to the Sun, then the distance is 147.3 million kilometers, and this position is called perihelion. What is it children? Perihelion. When the Earth's elliptical orbit comes farthest to the Sun, it is called aphelion. What is it children? Aphelion. And the distance is 152 million kilometers. Here in this picture we can see the Sun is not at the absolute center of the Earth's orbit. Also we can see how far our Earth is in on 4th July. Now different months, isn't it children? In different months it is written that our Earth position is different. On 4th July, the Earth comes farthest to the Sun, and 3rd January, our Earth comes, correct now children? Our Earth comes very closest to the Sun. When it is 4th July and 3rd January. Children, to complete one revolution, how many days does the Earth take? Yes, it takes nearly 365 days, 5 hours, 48 minutes and 45.51 seconds. We could calculate it 365 days, 6 hours. For 3 years in our calendar, we can see 365 days. Then, when it comes 4th year, total days will be 366, and we call this year as leap year. In the leap year, the month of February has 29 days, and in other years, February has 28 days. Children, we had already studied the Earth's axis is tilted. As we studied, no? Now we will see the effects of this tilt. Children, just imagine if the Earth's axis had been vertical, what would happen? See in this picture, fall of sunlight on Earth, we can see in this picture. All the place won't get equal amount of light. Only one side, no? Then next side. Children, we have already studied that the Earth's axis is tilted. Now 2-3 times I told. It is tilted at an angle of 23.5 degree from the vertical. That also already mentioned. This means that if a line were drawn parallel to the plane of the Earth's orbit, the Earth would make an angle of 66.5 degrees to this line. This tilt has some effect on the Earth. We know that the rotation causes day and night on the Earth. The duration of night and day is not equal in all places on the Earth. This is because the inclination axis of the Earth. If we look at the important latitudes on the Earth, it is equator, Tropic of Cancer, Tropic of Capricorn Arctic Circle and Antarctic Circle. Now, if you see the lines carefully in the southern hemisphere, you will understand that the duration of night is longer, and in the northern hemisphere, the duration of day is longer than the night. The reason is northern hemisphere is facing the sun. See in the picture. And the southern hemisphere is facing away from the sun. But if you look at the Arctic Circle and Antarctic Circle, the Arctic Circle is completely in day. So when the earth is rotating, the entire region beyond the Arctic Circle will have day. There the sun will not set. Whereas in the southern hemisphere, beyond the Antarctic Circle, you will see this completely dark. And here the sun will not rise. Now see in this picture, this line is carefully in the northern hemisphere. You will understand that the duration of day is longer, and in the southern hemisphere the duration of night is longer than the day. The reason is southern hemisphere is facing the sun and the northern hemisphere is facing away from the sun. But if you look at the Arctic Circle and Antarctic Circle, the Antarctic Circle is completely in day. So when the earth is rotating, the entire region beyond the Antarctic Circle will have day. Then in the northern hemisphere, beyond the Arctic Circle, you will see this completely day. Okay. The length of the day varies with respect to even seasons as well as latitudes. So the length of the day varies with respect to latitudes gradually. Now seasons are effects of revolution only. Because of the revolution of the earth, we have in the first phase summer. The second phase rains. In the third phase it is retreating monsoon, and the fourth phase it is winter. Now how does it happen? Suppose we take these four positions of the earth. In the first position the date is 21st of March. In the second position it is 21st of June. In the third position it is 23rd September, and the fourth position it is 22nd December. When the earth is in the second position, if you look carefully, the north pole is facing the sun. And when the earth is in the fourth position, the south pole is facing the sun. But when the earth is in the first position or in the third position, southern hemisphere first and third position, southern hemisphere and this hemisphere is facing the sun. So the inclination of the earth's axis does not have any impact on the sun rays it receives. So on 21st of March, vertical rays of the sun falls on the equator, and the entire earth has equal day and equal nights. But as it is moving from the first position to second position, slowly the northern hemisphere tilts towards the sun. So in the northern hemisphere the days become longer and the nights become shorter, and this gives rise to summer conditions, and we say in this phase it is summer in India. On 21st of June, the vertical rays sun falls on the Tropic of Cancer. This is the maximum inclination of the earth's axis of the northern hemisphere towards the sun, and this is referred to as summer solstice. What is it, children? Summer solstice, 21st June. As we come to the third position, again the day and night are equal, and in this entire earth has equal day and night. And as we come to the fourth position. The date is 22nd December. The 22nd December. The southern hemisphere is facing the sun and the vertical rays of the sun falls on the Tropic of Capricorn. And this is the time the northern hemisphere experiences winter solstice. Winter solstice. So the first and the third positions are referred to as equinox because it is equal day and night. The first position is referred to as spring equinox and the third position is referred to as autumn equinox. Isn't it clear now, children? Equinox, that is a first position, that is a spring equinox, and third position, that is a autumn equinox. Children, I will repeat about solstice and equinox. Now, because there are changes in seasons, there would be changes in the patterns of that sunlight and the spring we receive. So, in the north hemisphere, what happens is during the summer months, that is during predominantly the June months, you would have a very long day and very short summer. That's the point, a very far from the sun. This is what is known as the summer solstice. So summer solstice in north hemisphere would have lead to longer days and shorter nights. That's a specialty. Longer days and shorter nights. The longest day and shortest night would seeing on 21st of June. However, on the other hand, in the winter, what would happen? The nights would become very long and the days become very short. This happens in the month of December, usually around 22nd December, where we say we have the winter solstice. All the days are shortest and nights are longest. So summer solstice, you have the longest days and winter solstice, you have the longest nights. Reverse will happen in the southern hemisphere. When it comes to equinox, what happens is during the month of September and March, you have equal days and nights that you have seen. So, sun being at an equal distance from autumn equinox to vernal equinox, we would have equal days and nights that would be seen. You would have the autumn months where we would have the autumn equinox that would be seen, and this would be in the month of September. Usually we say 23rd September you have the autumnal equinox. And on the other hand, in the March we would have a vernal equinox. That occurs around the 21st of March where you have again equal days and nights. So the equinox, these two equinoxes would have equal days and equal nights. However, at solstice we would have longer days and longest nights. So in the northern hemisphere, summer solstice would have the longest days, and the southern hemisphere in December we would have the longest days, and vice versa occurs in the south. So that was the very fundamental understanding of the solstice and the equinox. So children, our lesson completed. I'll give you the notes. Okay, thank you.